Hi all, uh, good evening to you and welcome to the fifth live session on doubt clearing. So today we'll be looking at assignment number 5, which basically deals with the polarity, the dot conventions to be clear, to be precise. So we'll be working with the dot conventions on inductors. So we'll be solving the assignment problem. And I hope that the assignments, the problems of the previous week, which we solved together, was also clear to you. So I will be just sharing my screen, and I have allowed the mic for both of you guys. In case you have any doubt, you can just unmute and say. So I hope you are able to see my screen. Could anyone just raise their hand and let me know? Just confirm once. Can anyone just let me know whether they are able to hear me and see the screen?
Uh, Sir, your voice is audible, sir.
You can see the screen, right?
Yes, sir, I can see your screen, sir.
Okay, thank you. Thank you. So we'll be looking at these problems today. Now, before going to that, I'll just show the basics of what is dot convention and all. Some of the basic, equations, the current voltage, the KVL equations, and then we'll start going. So this is also a pretty simple concept to know. I mean, it's not that complex. If you listen attentively, you will be able to understand most of it. So, these. So basically, this dot convention, this uh, this deals with inductors only. So as you know that when so suppose there is an inductor, so inductor is nothing but turns coils of specific turns n, and when you allow a current through to flow through this coil, there is a voltage induced, which is given by this minus L di dt, right? And why minus? Because it's basically comes from Lenz's law. It opposes the cause, that is the flow of current through it, right? So this would be rather capital I. Now, this is the basic of the inductor, the Lenz's law. I mean EMF, equation of EMF, right? V equals to L di dt, rate of change of current flowing through the inductor multiplied by the inductance value. Now, let us draw a diagram something like this. So, the, there is a voltage source of, let's say, Vs, and there are two inductors connected in series, and there is here. So these dots are nothing but the dot I was talking about. So I'll come to this, and let's say that the current is flowing in this direction, right from, so this is basically positive and this is negative. So this should not be confused with a DC source. This is rather an AC voltage source, where plus represents that the current is flowing from this point to this point. I mean from upward to downward. And now let's say that the mutual inductance between these two inductors be M, right? And the individual inductance of these two inductors are L1 and L2. So what would be the voltage equation of this? So if you apply KVL, it would be nothing but Vs equals to uh, L1 di dt plus L2 di dt, right? This would be the simple voltage equation provided there is no such dot conventions. But since we are given these two dots here, they do represent something. So basically, the meaning of this dot is that uh, I mean since the current is flowing through one of the inductors, it would induce some voltage in the other inductor and vice versa. So since current is flowing through inductor L1, it would induce some current flowing through L2, inductor L2, and also since current is flowing through L2, it would induce some voltage in L1. So that is the basic, physical interpretation of these dots. Now, how to represent it in a form of the equation? So see, this if I remove the circles here, so these dots here, uh, the current that is flowing through this, entering this inductor, so it is entering the inductor where the dot is present at the top, right? So this I is entering L1 where the dot is present at the top. Similarly, the dot is present at the top, at the upper side of L2 as well, right? So therefore, we will say that, if this happens, then we will say that the voltage that is induced by inductor L1 on L2 would be the same as that of L1 as well. So basically, same means the sign would be same. So if I write in this equation, it would be something like this. So there would be this mutual inductance M, right? And we would write something like this. So this M di dt, this is the voltage induced by inductor L1 on L2. Okay, and again there would be another this thing, this term, and this would mean that this is the voltage that is induced, sorry, by on L1. Y plus y, both these terms are plus because the current that is entering this dot is both on the upper side of L1 and L2. So if this would have been my here, so instead of here, this, if this dot would have been at the lower side, sorry, at the lower side of L2, then this thing would have been minus instead of plus, because that the current is entering through L1 where the dot on L1 is on the upper side. Similarly, the L2, the dot is on the lower side. That is why this minus is there, nothing else. Okay. So this is the basic thing. So therefore, the equation would be something like this: L di dt plus L2 di dt plus 2m di dt. So this is the basic, equation or way to solve this. Now, in certain cases, we would be given with the, so these are what? Let's erase this, jot it down. Okay, so this is what? L. These are nothing but inductances, right? L to M. These are nothing but inductances. But in the problems that we will be solving now, we would be given with the inductive reactance. So, for example, XL1, that is inductive reactance of inductor 1, then XL2, then XM. So, this is nothing but inductive reactance, right? We saw in the previous live session, right? Therefore, the in such cases the equation would modify like this. So this would be nothing but xl1 I1 plus xl2 I2 plus x, or so rather, sorry, would be for this equation, this would be I only, right? So then xmi plus again xmi. So I mean, if we want to replace this L di dt with the inductance, I mean, we want to replace this L1 with inductance, then this part would be nothing but the inductance or inductive reactance multiplied by the current flowing through the inductor, right? Voltage drop across the inductor. So resist, basically the resistance into current, simple thing. So this would be nothing but something like this. If we are not given with the inductance, if we are given with the inductive reactances, then the equation would change and it would look something like this. Okay. Uh, so I'll just stop here and ask, I mean, whether you have any doubt or not. If you have, you can unmute and speak. I'll just show another simple thing and then we will go straight into the problem.
No doubt, sir.
Okay, Prakash, you have any doubt?
No doubt, sir.
Okay, thank you for responding. So let us take a simple, inductor transformer problem. So here there is one inductor, and here there is another inductor, and let's say that the dot is presented this side of the inductor whose inductance is L1 and this is L2, and let's say the dot is presented this side, and let the mutual inductance between these two inductors are M. Okay, I hope you know what is mutual inductance, because this is plus 2. I mean, you have studied in your 11 12, right? It should be known to you. So let's say that the current that is flowing through the inductor 1 is from this side, right? From left to right, and similarly here it is from right to left. Now, what would be the equation of the voltage? This part, the left hand side. So let's say this is the primary part, and this is the secondary part of the transformer. So the what would be the equation for the primary part? This would be nothing but V1 L1 di1 dt, right? Then there would be minus, okay, minus di1 dt. Why minus? Because see here, the current is entering through the inductor where the basically the dot is on the upper side, right? On the other hand, for the current for the inductor 2, the I2 is entering the inductor L2, but the dot is present on the lower side. That is why this minus is there, nothing else.
Sir,
This is pretty. Hello.
M di2 y dt, does, sir? Hello, sir.
Sorry.
Minus
Yes.
M di2 y
Yes.
dt.
Yes. 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 Sorry. Yes. Thank you. Right. Similarly, what would be V2? This would be L di2 dt minus M di1 dt. This is the simple thing here, nothing else. So if instead of here, if this dot would have been here, then both of these things would have been plus. Okay, nothing else. Because why? Here also the current is entering from the side of the inductor where the polarity is on the upper side. The dot is on the upper side, right? So that is why plus, nothing else. Pretty simple. I hope this you can understand that. I mean, get go only. You don't need a second explanation. Pretty simple. Okay. I hope this is understood. If not, you can tell, because these are the basic, pretty basic things in circuit theory. Okay. So I hope this is clear that. Okay. So let us go ahead with this problem. Here, as you can see, this is nothing but what you can say, a transformer only, where there is an inductor on this side, and there are two inductors on this side, and the mutual inductances are given. So these arrows that is shown here, these are nothing but inductances only. And this load, there is a 40 ohm resistor connected as a load between terminal B and C. Okay. Now here there are three questions. They have told us to find out the RMS value of I1, I2, and also the potential difference between A and B. So as you can see that the voltage here, the source voltage is nothing but the RMS voltage. So whatever value you get, that will be in RMS only. So they have, in a way, they have tried to confuse you by writing estimate the RMS value. So don't get confused. You don't have to divide it by root 2, because the voltage value is already in RMS, root mean square. Okay. So let us quickly write the different terms. I won't draw the circuit again because it's already given. It's pretty simple circuit to understand at least. So what would be J36 ohm? Okay, because why, this is the reactance. So this is our L1. This is L2. Okay, let me just use a different thing. This is L1. This is L2. This is L3. Okay. Therefore, XL1 is J36 ohm. What is XL2? XL2 is J4 ohm, and XL3 is uh, J49 ohm. Okay. What is Vs? It is 100 volts. I am not writing RMS because it's already specified. No need to write. Now be careful about this. What is, again, let me use a different thing here. Now what is the mutual inductance between L1 and L2? It is J8.4. So let us write it using M1. Okay. So what is the mutual inductance between L1 and L3? That is J8.4. Let us write it as M2. And what is the mutual inductance between L2 and L3? It is J11.2. So let us write it as M3. Okay. This will help. I mean, there won't be any confusion while we are describing the terms, right? So XM1 would be J8.4 ohm, and it is nothing but equals to M2, and XM3 would be what? It is J11.2 ohm. Okay. Now we have what? We have two meshes. We have two mesh, so we will be applying KVL, right? So we require mesh. So this is the first mesh, and this is the second mesh, and the direction of currents are given. So current is flowing like this here. This is I1, and this is I2, right? Therefore let us quickly write the KVL, and we'll try to complete it quickly today. Okay, there are no extra problems. I haven't kept any extra problems for today. I'll see for next assignment. I'll see. Okay, so let us solve the first mesh. Uh, what would be the equation for the first mesh? This would be Vs equals to I1 into XL1, but we won't stop here, right? Because there is mutual inductances. Now carefully see here, I2, it is entering through the through this dot part. I mean, it is moving like this. I mean, it is flowing in clockwise direction, and it is entering through the positive the dot part, or dot. Basically I am trying to say it is positive because it is entering through the that polarity part of this inductor L3, right? So that is why I am saying positive. So it is entering through the this side of L3. So therefore we will write M2. Why plus here? Because I1 is also entering through the upper part, that is the positive part of L1, right? So that is why this plus is there, and M2, and this would be what? I2, sorry, not M2. This would be XM2, right? This would be XM2, and this would be I2. Then as you can see that I will be flowing through here, and it would be entering through the negative part of inductor L2, right? So therefore minus would be there, and this would be what? Xm I2. I hope this equation is clear. I'll just stop here and ask you guys whether it is
Clear,
clear or
sir.
not. Okay, Prakash, is it clear?
No, sir.
It is clear, na?
Sir, clear, sir. No doubt, sir.
Okay. So as you can see that these two terms will get cancelled, because why? Xm1 is equal to Xm2, right? We just saw here. So therefore this term will get cancelled. Therefore what would be I1? It would be nothing but Vs by XL1. So what is Vs? It is 100, and what is XL1? It is J36. So therefore this would be what? This would be 25, and this would be 9. Can you guys please say, just tell me what is 25 by 9? Quickly calculate and then tell.
2.77.
2.7. And why this minus j is there? We already saw, because we already know, right? If we have something like 1 by j, we can multiply it with both numerator and denominator as j. And we saw that in the previous lecture, we saw that j square is equals to minus 1, right? Therefore basically I remove this part here, j
Got it,
divided
sir.
by 1. Yeah, so this is minus j. So that is why this I1 is minus 2.77. Now they have told you to calculate what is the RMS value. So simply you need to write the magnitude of I1. It is nothing but 2.77 ampere. This is the answer to first part. Now what is I2? We need to solve the second mesh. Uh, Second mesh would be what? It would be, let us write. So first of all, I2 into 40, right, plus I2 into this J49, right? I am not writing the terms here, I am just directly writing it. I2 into J49 plus I2 into the other inductor. This is J4, Now the mutual inductance between these two inductors, right? What is this? This is J11.2, but here, um, see here, this I2 is entering through this side, right? The positive part of inductor L3, because the dot is present on the lower side. On the other hand, the dot is present on the other side, upper side, right? So it is basically entering through this negative terminal. So therefore, there would be a minus here, minus I2 into this thing, right? J11.2. Now this is due to the inductor L3. This thing is due to inductor L3. Similarly, there would be another inductor, I mean, mutual inductance turn due to inductor L2, and this is again the same, right? Because the value is the same. Therefore, the same thing will again get repeated, J11.2. Now, what would be the mutual inductance between this J49 and this thing? So this is nothing but your so this would be positive, right? Because the current is flowing through this part, and the I1 is flowing through this part, right? So entering through the positive side, this is also entering through the positive side. Therefore, plus I1 into J 8.4, right? And here it will be negative because I2 is entering through the negative part for this inductor L2, and here it is entering through the positive part. So therefore, minus I1 into J 8.4, and this will be equals to 0, right? So here clearly you can see these two parts will get cancelled.
ये तो fitting में
Hello.
Yes, sir.
Do you have any confusion or any question?
No, sir.
ठीक है।
Okay, okay. So here we can, I mean, what are the terms that are left? This is I2 into 40 plus I2 into J49 plus I2 into J4 minus I2 into J11.2 into 2, right? There are two terms here, so I'm writing into 2 is equals to 0. Now here you can easily take I2 common, right? So J4 minus J11.2 into 3. Now clearly this term can't be 0, so therefore I2 will only be 0, right? So therefore I2 is 0. And this is the answer to the second part. So RMS value is 0. So I hope this is clear to all, both
Yes,
of
sir.
you. Akash, is it clear?
Yes, sir.
If you have any doubt, you can ask.
Yes, sir.
Okay. Okay. So now, what is the another question? What is the find the potential difference between VAB? Okay. So VAB means between this point and this point, right? Between this point and this point, and between this point we have this inductor J4 here, right? So with this inductor J4, VAB would be what? I2 into J4, right? The inductor L2 J4. Now we will also have the mutual inductance values also, right? So I2 into J4. Now with this, we already saw that it is minus the mutual inductance, the direction, right? So it is minus I2 into the mutual inductance, inductive reactance value is minus J11.2 plus y plus, because with this and this, no, this would be minus, sorry, would be minus, sorry. This would be minus, we saw, right? With this inductor, the mutual inductance value is minus, right? So this is I1 into J 8.4, right? So this is the potential difference across VAB. Therefore, this would be 0 and this is 0. We already saw I2 is 0. Therefore, this is I1 minus I1 into J 8.4. This is the value of VAB. Now, what is I1? I1 is we won't replace the RMS value. We'll just replace this. So this is minus J 2.77 into J 8.4 volts. So this would be what? Minus J is minus 1, and minus 1, I mean minus and minus is plus, so we will have 2.77 into 8.4. Can anyone calculate and tell me the value?
23.26.
22.26.
Yes, sir.
22, acha, 22.26.
23.
Oh, 20.
23.26.
Okay, okay. 23.26. Okay, so this is the answer. This is the answer to the third part, right? What is the value of the RMS? Potential difference between VOC. So let's just do the difference to highlight the answers. This is answer 1. This is answer 2. And this is answer. So I'll just stop here. And if you guys have any doubt, you can ask.
No doubt, sir.
Okay. 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 So if you don't have any doubt, we'll proceed to the next part here. So the next part consists of three sub-circuits, right? And these are the questions. So we need to calculate what is the RMS value of I1, I2, I3. Okay. Now, so let's again describe the different inductance and mutual inductance values as we did for the previous problem. Right. So here this inductance value is given, right? So let us say this is L1, this is L2, this is L3, this is L4, this is a capacitor C. Now let us write the mutual inductance value. This is M1, right? And this is M2. Yes. And again we need to use KVL in this problem because we have three meshes, right? So this is I1, this is I2, and this is I3. Okay. Now let us write the different parameters. So Vs is 100 volts, again RMS, right?
Sir,
M1 is what? Hello.
sir, potential across VAB is equal to minus 23.26.
Minus or plus? It should be
Minus
plus.
23.26.
Why minus?
Sir, because minus J square is equal to minus
Hmm.
1.
And 4, right? So I1 was what? Okay. I1
Yes, sir.
was okay. Sorry. Yeah. So this would be minus. Yeah. Sorry. So this would be minus, and this would be minus. But they told you to find out the RMS value, right? So that's the
Yes, sir.
magnitude. So
Yes,
this
sir.
would be VAB would be 23.26. Yeah. Thank you. Thank you. Okay. So in the next problem, what is XM1? It is J9.6 ohm. What is XL1? It is J16 ohm. XL2 is J36 ohm. Uh, XL3 is how much? J49 ohm. XL4 is how much? J4. And XM2 is J8.4. And your XC is J15, right? So let us solve the first mesh, because we need to calculate each of these things, right? So we need to solve the equations of each and every mesh, right? So what would be the equation for the first mesh? It would be Vs equals to um, your XL1 into I1, and here as you can see that the I1 is entering this dot terminal, that is the plus terminal of L1, but I2 it is entering the negative terminal, right? It is not entering, it is exiting through the dot terminal. So therefore this would be X minus XMI2, right? I hope this
Yes,
is
sir.
clear. So this would be what, 100 volts equals to XL1J16 into I1 minus XM is how much? J9.6. I hope this is clear for the rest of the people also. Prakash and Manikananda, it is clear for you guys also.
Yes, sir. Clear, sir.
Sir, clear, sir.
Okay, thanks. So let us write the second mesh. Second mesh is what? This thing, right? So let us write all the terms related to I2 first, then we will look at the mutual inductance part. So I2, I'll write a bracket here. So J49 plus J36, right? J36 plus J36. Hmm. Now, see here, there would be two mutual inductance term, because here we have two inductors where the first inductor, I mean this L2, the second inductor is coupled with L1, mutually coupled with L1, and the L3 is mutually coupled with L2. So there would be two, but there is no mutual coupling between these two inductors, right? L2 and L3, there is no mutual coupling. Please don't get confused with that. There is no mutual coupling of L2 and L3, because as you can see, there is a mutual inductance between L1 and L2, and there is a mutual inductance between L3 and L4, but no mutual inductance between L2 and L3. Therefore, no mutual coupling between these two inductors. Okay, so please be clear with this. Okay, so let me just close this bracket here. Now, this thing would be what? So as you can see that I2 is entering through the negative part, that is the lower part, not through the dotted part of L2, and I1 is entering through the dotted part of L1. Therefore, this would be what? Minus J 9.6 I1. Okay. Again, sorry. Again, here I3 is entering through the negative part of L4, but I1 is entering, I2 is entering through the dotted part of L2, L3, right? It is entering through the dotted part of J49, but I3 is entering through the negative part of J4. Therefore, again minus, right? And how much is it? 8.4 I3, right? So I'll just stop here. I hope this is clear. If you have any doubt, you can ask. I hope it is clear, right? It is pretty simple. That is why I'm going slowly. I'm not hurrying the things. So what is 49 plus 36? It is 5785, right? So it is J85 I2 minus J9.6 I1 minus J 8.4 I3, right? Now let us write this equation as I1 and this equation as 2. Now we need to solve the third mesh also, right? What is the equation for third mesh? So we have an inductor and capacitor, right? So this would be I3 mm, J4 minus J15, right? J4 minus J15. Again, this would be pretty easy, right? So this would be minus J8 for I2. Why minus? Because the current through the inductor is flowing through, entering the negative of J4 L4, and it is I2 is entering through the positive of J49. So this is minus I2 J8.4, okay, and this is 0. So this would be minus J11 I3 minus I2 J8.40. So this would be what? J11. So let us take J and minus common. I3 plus 8.4 I2. So let us just substitute I3 first, because we need to calculate I1, right? So this would be I2, and this, let us write it as equation 3. Now replacing 3 in 2. Okay, so 3 in 2 means what? J85 I2 minus J9.6 I1 minus J8.4 into minus of 8.4 divided by 11 I2. Okay, so this would be what? So let us take J also to the other side. I mean J common, and let us take J common. So what it would be? I2. This minus and this minus would become plus. This should be 8.4 into 8.4 divided by 11 I2 minus 9.6 I1. This would be equal to 0. Okay. Um, so this would be what? Can anyone help me? So this would be what? I2, if I take I2 common, 55 plus 8.4 square divided by 11 minus 9.6 I1 equals to 0. So can anyone help me with this part here? 85 plus 8.4 square divided by
91.41.
91.41. So 91.41 I2 equals to 96 9.6 divided by 10. So 9.6 divided by 91.41 I1. Also, please calculate and say tell me the value of 9.6 divided by this thing, 91.41. Let me take this to that.
0.105.
Okay, thank you. This is 0.105 I1. Right. So let us write it as equation 4. Therefore, what now we will now do? See, we if you look at equation 1, we have I1 and I2, and if you look at equation 4, we have I1 and I2 again. So what we will do? We will replace 4 in 1. Okay. So it was what 100 equals to J16. Let us take common J minus what it was 9.6 into 0.105 I1. Can anyone tell me this value? 16 minus 9.6 into 105. Hello?
14.992.
So this is 14.992 ampere, and 100 by 14.992 is how much?
6.670.
6.67. So therefore we have got the answer to the first part, right? So they have told us to estimate the value of RMS value of I1. So RMS value of I1 is nothing but the magnitude of I1 is 6.67 amperes. Okay. Now what is I2? Again I2 and I3 we need to calculate, right? So I2 would be what? Magnitude of I2 would be what? 6.67 into 105 amperes. What is this value? 6.67 into 0.105.
0.7.
0. So this is 0.7 amperes. And RMS value of I2 would be what? It would be J 6.67 into 0.105. Right, so this would be minus zero point 0.7 amperes. And I3 would be what? I3 would be minus 8.4 by 11 into your J. Okay, so this is minus, right? And this whole is 15. So again, 8.4 into zero point 0.7 by 11 is how much?
0.534.
Okay. So we have got the values of I1, I2, and I3. Now they have told us calculate V2 and V3. So V2 is what? The potential difference across either L2 or L3 you can calculate like this, and V3 is what? Potential difference across L4 or C, whatever, in what way, I mean, you can calculate the potential difference across L2 or L3, right? You will get the same answer. You have to get the same answer because it is essentially the same, right? And similarly this way. So I will be calculating V2 as, so let's say we do something like this, that I2 is V2 into L3. Okay, so this thing, the third inductance. So I2 into X L3. So I mean, not only this. So I mean, if we consider, my main reason of saying this thing is that, see here, for calculating V2 you can consider L3 as or L2, any of this thing. Now if we consider L3, you need to consider the mutual inductance as well as L3, right? You need to consider M2 as well as L3. Okay, and if you consider L2, you need to consider L2 as well as M1. Okay, so similarly for this thing also. So if you consider C, you don't have any mutual inductance, right? Because capacitor, it doesn't have those dot convention or all anything like that. But if you consider L4, you need to calculate the potential difference across this, and also the M2 you need to consider. Okay, so this is pretty straightforward. So I2 into X3 minus, so there would be obviously a minus what? So L3 is this, so XL3 minus I3 XM2, right? So minus I2 X M2, right? So therefore, um, this would be what was I2, and here we need to consider the actual values. Okay, we can't consider the RMS values. Here I2 was this value, right? So minus zero point 0.7 into what was XL3. XL3 was 40 J49 minus sorry, this would be I3, and I3 is this, right? So minus J534 into J um, 8.4. Okay. So therefore, this minus and minus will become plus. Similarly for this, so we will get something like 49 plus 534 into 8.4. So this will be V2. Can anyone calculate and tell me what is the value of this? Hello? Can anyone calculate what is 0.7 into 49 plus this thing?
$38.78.
Okay. 38.78 volts, right? So this is the magnitude. So magnitude would also be the same, right? So there is no confusion here. Now let me also calculate V3. After that, I'll stop and ask you guys whether if you have any doubt. So V3 is what? Either you calculate the voltage across this capacitor or this inductor. Now to make things simple, I'll calculate the voltage across the capacitor, because if I do across the inductor, I need to also consider this M2. So extra calculation basically. Therefore,
Yes, sir.
V3 would be what? V3 would be I3 into XC. So I3 was how much? It was 0.534, and XC was how much? It was minus 15. Yes. So minus J15.
J
Again,
plus हो
minus and
जाएगा
minus plus. So how much
into,
is this value? 15 into 0.534? Half of it, right? Slightly more than 8 around, I think.
yes sir, 8.01.
8. Okay. So this is the answer to your what we had. So this is answer 7. This is answer 8. This is answer 6. This is answer 5. And this is answer 4. Or rather, this is the answer 5, right? Because you need to calculate the RMS value. So I'll just stop here. And if you have any doubt regarding how we calculated V2 and V3, you can ask. I'll just stop here. So Manikananda, you have any doubt? in question 2?
Sir, yes, sir. While not
Ah,
with respect to question 2, sir,
ah.
that previous question I'm having doubt when I was do that. So can you please, if time permit, can you please explain that first summer, sir?
We have a lot of time. Which question? The previous question, right?
Yes, sir. This question only, sir. Because I am late to so only, sir.
Okay. So let me solve the third question, then we will solve the last question. After that, we will go through this question. Is that okay?
Okay, sir. No problem.
Okay, okay, okay. So now see here. In this question, this is a simple transformer kind of a circuit, right? And so again, let us quickly mark the different components. So this is your L1, this is your L2, this is M1. Now mm, current is flowing like this, I1, and this is I2, right? Now clearly you can see it is that this current is entering through this negative terminal here, and this is entering to the, so kind of we can represent kind of this. Okay, so if we have an inductor and something like this, and the current, so we can, we can think like this, that this means that this is something like this, nothing else, so with the current convention. Okay, so this something like this, so that is why I have written this plus and minus here. It helps you to solve the problems quickly. So now they have told us here, so there are straightforward four questions, but in the first question they have told us to estimate the coefficient of coupling between the two coils, right? So these two coils are coupled, and there is a term called coefficient of coupling, which basically is a, what can I say? It is a parameter to estimate how good the coupling is, nothing else. Coefficient of coupling, it is denoted by K, and K is given by M divided by L1 into L2. So I should not write M1 here, right? So since there is only two conductors, two inductors here, so only M would do, right? So now here you can see, so Vs is 80 volts, uh, XL1 is how much? J9, XL2 is how much? J4, and XM is how much? Is J3. Now here you can see we don't have the values of inductances, right? We have the values of inductive reactances. Therefore, how to calculate the mutual coupling, that is K. So it is pretty simple. See, what is XL1? It is nothing but 2 J 2 pi f L1 or J omega L1. Similarly, XL2 is what? J 2 pi f L2. It is nothing but omega L2. And similarly, XM is J omega M. Therefore, your XL1 is directly proportional to L1. XL2 is directly proportional to L2, and XM is directly proportional to M. And therefore, this equation here we can rewrite something like this. So XM divided by XL1 into XL2, right? Because since these are directly proportional, why? See, we can prove it, right? We can directly prove it. Our initial equation was what? Km L1 into L2. So what is M? M. So if we substitute this, uh, M would be what? It would be Xm divided by J omega xm divided by j omega. Similarly, what would be this thing? L1 would be xl1 divided by j omega into xl2 divided by j omega, right? Now, what would be k? It would be xm divided by j omega divided by xl1 into xl2 divided by j omega square. Now this whole thing is there, right? So let me just erase this. I can't erase. Anyways, so this is whole thing, right? So therefore, this would be what j omega divided by xl1 xl2 divided by j omega, right? Because this square 1 by 2 will cut. So therefore, this thing would get cancelled, and therefore we would have something like this, right? So this is how we can prove that k is. We can also write k as xm by xl1 xl2 whole root, right? So this is pretty simple. This is, I hope this is clear. I need a quick response from you guys. I hope this is clear.
Yes, sir.
Okay. So k would be what? Xm is j3, and your this is j9 and j4 whole root, j9 and j4, right? So j squared into 36, right? So j3 divided by j6, nothing but 1. So this is the answer to your question. Now they have told us to find out the value of R1, so therefore I1, sorry, we need to write the equation of mesh 1. So mesh 1 is what? The 80 equals to I1 into J9 minus I2 into J3Y minus, because I2 is entering through the negative part of L2 and I1 is entering through the positive part of I1. Therefore, your 80 equals to um, how much this was? 9 I1, right? So J9 I1 minus, it was J3 probably, right? Very nice. J3. This is your first equation. And it's very simple, right? This is mesh 2. What would be mesh 2? Mesh 2 is I2 Ji4 minus I1 Ji3, right? I2 J4 minus I1 into mutual inductance Ji3. So therefore I2 is 3 by 4 I1. Now we will just replace this. So replacing 2 in 1, so 80 J9 I1 minus J into 3 by 4 I1, right? So J I1 common, 9 minus 9 by 4. So basically I1 is 80 divided by J, 9 into 4 is 36 minus 9 27 into 4. So can anyone quickly tell me what is this value? 80 into 4 divided by 27.
11.851.
11.851. So this is what is the value of I1, right? And I2 would be what? I2 would be J 11.851 into 3 by 4 ampere. So what is this value? Into basically into 0.75. 11.81 into
8.888.
8.8. So RMS value of I1 would be 11.85, we need to consider the magnitude only. Similarly for I2. Now the next question is estimate the impedance in magnitude seen by the source. So what is the impedance seen by the source? It is nothing but I mean, what
Vs
would
upon
be the,
I1.
yes, exactly. Yeah, simple. So impedance seen by the source would be the source voltage divided by the current that it is supplying, right? So if and they have told us to consider only the magnitude. So it would be 80.80 divided by 851 volts. How much is this? Sorry, this would be ohm. Sorry. How much is this?
7.42.
8.75.
80
Yes, sir.
divided.
Yes,
I
sir.
got two answers.
6.75, sir.
Ah, yes. So therefore, let me just quickly write. So this is the answer to question 12. This is the answer to question 11. Answer to question 10, and this is the answer to question 9. Uh, So this is all about today's assignment. I'll quickly try to explain and we will end today's session. We don't have any extra problems for today. So I hope this question was clear, right guys? Pretty simple.
Yes, sir. Clear.
Manikananda, it was clear for you?
Yes, sir. Final question. Understood.
Okay. So let us solve the see the first question again. So here this circuit is given, right? Basically a transformer with one coil on the primary side and two coils on the secondary side, right? And um, see here you have this inductor L1 is there, this inductor L2 is there, this inductor L3 is there, and the load is connected between terminal B and C, a 40 ohm resistor. Now these two will have a mutual inductance whose value is J8.4, and this is mutual inductance M2 of 8.4, and these two inductors again they are also coupled and they have a mutual inductance of J11.2. Now they have told us to find out the I1, right? So here we have written all the necessary terms, and while solving such a kind of problem, when you have so many terms given, you need to write, I mean, for your comfort, for your ease, I have shown all the terms here. Okay. So we are writing the first mesh. It is nothing but Vs equals to, so I1 is flowing in clockwise direction. It is I1 into XL1. Now plus XM2. Why plus XM2? So this M2 is this thing. Now clearly you can see here. So we can write this as something like this. So this is plus, this is minus. Here also this is plus, minus. This is sorry. Now here this is minus plus, right? This is minus, this is plus because this dot is downward. So here I2 is entering through the plus terminal and I1 is also entering through the plus terminal of L1. Therefore, plus XM2, okay, into I2 obviously. Now why minus XM1? Because I1 is entering through the negative terminal of L2, right? And I1 is entering through positive terminal of L1, therefore minus. No, the two polarities are different, right? I mean, in the way the current is entering through the two inductors. Therefore, these two gets cancelled, and you calculate your I1. So I1 is 2.77 amperes. Now they have told us to write the value of I2 also. In the same way you write I2 also. So be careful. We have a big term here because there are a lot. So there are two inductors, right? And there is a resistor, and each inductor is coupled with each of the other other two inductors. So therefore we have such a big term. Now if you also try to solve this is pretty easy. Thus the equation is to some extent big. But if you try to solve this, you will get something like this, and you can take I2 common. So here also you see I1 and I1 will get cancelled. So these two terms will get cancelled because of this reason. So this is oppositely coupled. So L2 and L1 are coupled oppositely. On the other hand, L1 and L3 are coupled in the same direction, right? We saw I2 is entering through the plus terminal of L3. I1 is also entering through the plus terminal of L1. So that is why this two terms will get cancelled, and your I2 will come to 0. Okay. So this is the answer to
Sir,
the second. Yes. Yeah.
sir, that writing that second equation only, I have that doubt, sir.
Tell.
Can you explain that
Okay.
how
Okay. Okay.
that?
Okay. I'll tell you. Yeah. Okay. So see, I2 into 40, right? So you are simply applying KVL in this loop. There is no voltage source. That is why this is equals to 0 here. So I2 into 40 plus I2 into J49 plus I2 into J4, right? Now I have written minus I2 J11 too. Why? Because see, we are considering these two inductors. So we have to consider the mutual inductance of L3 with L2 and also L2 with L3. Okay, both these two things, because we are considering both the inductors in the same mesh, and both are coupled oppositely, right? They are mutually coupled but in the opposite manner. Why? Because I2 is entering through the positive terminal of L3 and it is entering through the negative terminal of L2. That is why minus I2 into J11.2, again minus I2 into J11.2. Why two terms of two same terms? Because in the same loop, this is the same loop, right? In the same loop you are considering the two mutually coupled inductors. So minus I2 into J11.2, it is coming because L3 is coupled with L2, and again this term is also coming because you are considering L2 and L2 is coupled with L3. Okay, so therefore these two terms are coming. And again these two terms are y I1 into J8.4. This is L3 and L1. See here, I2 is flowing through L3. Here it is entering through the positive terminal of L3, and I1 is also entering through the positive terminal of L1. Therefore I wrote plus here, I1 into J8.4, and again minus I1 into J8.4. Why? Because I2 is entering through the negative terminal and I1 is entering through the positive terminal. Therefore minus I1 into J8.4 equals to 0. Therefore these two terms get cancelled, and finally when you solve this you get I2 equals to 0. Okay, I hope this is clear
Sir,
now.
sir, sir, one doubt, sir.
Bolo. Yes.
Sir, that mutually coupled coil, I mean mutual coupled inductance due to L2 and L3 is there, no, sir?
Uh,
That coupling, how it's happening, sir? Actually, it is due to current flow I2,
See,
whether it is
you need to understand the concept, right?
because sir,
Hmm,
that yes, sir. Because I1 is flowing, I1 is
hmm,
inducing current I2, both
yes.
having same current. Due to I1 only
Okay.
flux is producing.
Yes.
Then
Yes.
how it's arranged, sir? It's like a three-phase kind of thing. Other because the
No.
part inductance is isolated now. I mean primary inductor.
No. 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 First of all, why three phase? I really don't understand. Why three phase?
Because sir, what I was thinking now, okay, it is due to three inductor is winding in the same core, like that I was thought.
No,
Because
no,
all
no, no.
having their own mutual inductance now. So I thought like, okay, this was like that
See,
kind of stuff.
three phase would be
Then I was,
something like this, na. Three phase. So if you have an inductor, it would be something like this, na. It would be something like this, right? This is three phase. So here one wire, and here one wire. So this is L1, L2, and L3. But this, how can you consider this to be a three phase? These are two inductors which
no
are
sir, I
connected in
not
series.
considered, but I thought because all are having its own mutual inductance now.
So how will an inductor can have mutual inductance with the other inductor. So that doesn't mean that it will be a three
Sir,
phase.
this actual circuit, how it will coupled, sir? If we implement this in actual circuit now, how it will be?
See, let's say there are two inductors, right, which are connected in series. Now, as soon as you allow a current to pass through this inductor, there will be some flux developed, and this flux, there would be some flux developed in this also, right? So this flux and this flux will cut each other, right? So as a result, there would be some
Yes, sir.
mutual coupling between these two inductors, which is M. This is only
Okay,
what is
sir.
happening here. That is why you see there is a mutual coupling between mutual inductance between L2 and L3. Simple concept.
Sir, because I2 is zero, na, sir. How it, sir? Without current, how it
Arey,
will?
yaar, I2 is zero, but that how did you know I2 is zero? Well, you solved this problem to know, then you know, came to know that I2 is zero, right? Before solving the problem, I2 wasn't zero. But if I2 wasn't zero, there,
After getting that I2 value only, I got this out, sir.
yes, but initially, how will you know, right? You need to go by the concept, na? That if there are two inductors, so let it be something like this also. So even if these inductors weren't connected in series, right? If these were connected in parallel, something like this, and let's say this is I, and this is I1, and this is I2. So there would be some flux developed across this inductor. There would be some flux developed across inductor, and this phi 1 and phi 2, this would cut each other, and there would be some mutual inductance of M. So this will happen in series connection. This will happen in parallel connection. This will happen in three-phase connection everywhere, right?
Okay, sir. Okay, sir.
That is why these two terms are coming, right?
Oh, okay, sir.
You
Understood, sir.
understood this concept, right?
Yes,
It
sir.
is the mutual
Now it's
flux is coming. Why? Because of flux linkage of inductor 1 with inductor 2, nothing else.
okay, sir. I was try to imagine as physical mode, sir. How if we implement the circuit now, how it will be the two coils in one core and one coil in another core, sir.
No, this is not in another. This is in the same circuit here. Why is it in another code? This is the same circuit. Now you can see, you see what is an inductor. You take a wooden rod and you take a copper wire and you wound. Let's say you wound a copper coil where the number of turns is 5, and again you wound it. Something like this you need to do. Or let's say you take another something like this you need to do. Na? See, there is a uh, uh, let's say wooden coil, right? So this is and here there is a copper wire, and here you are wiring it, and here again you are wiring it, right? And after that it is going and connecting to a resistor. So this is your L1, this is your L2, and this is R. This is how the circuit is formed. And this may have a turns of n1, this may have a turns of n2, nothing else.
Okay, sir.
This is what is the circuit. And here also there was maybe a copper this thing where this thing was turned, and here there was a vs, right? Since something like this, this is the circuit. I hope this is clear.
Yes, sir.
Okay. So now you calculate I2, it is 0, right? So now this is the answer to the second question. Now what is the RMS value of potential difference between VAB? It is nothing but the potential difference across this L2. But just simply, multiplying I2 into J4 won't give the answer, because your L2 is mutually coupled with this inductor and this inductor, right? So you know the directions how to write it, right? So I won't be explaining this equation. It's pretty simple, right? This inductor is mutually coupled with L2 is mutually coupled with L3 and L1, and both are in negative directions, because I2 is entering through the negative part of L2, I1 is entering through the positive part of L1, and I2 is entering through the positive part of L3. So that is why this minus sign is there. And this is 0, this is 0, and we have a value of I1. So see, even though no current is flowing through I2, but we have a potential difference across the inductor. This is the physical significance of coupling, right? So even though we don't have a current flowing through the inductor, we have a potential difference across the inductor. Why? Because it is mutually coupled with L1. Simple, right? I hope this is clear.
Yes, sir.
Also the physical interpretation. Why, even though there is no current, we are getting a potential difference. Probably this is why the problem was given, to also to physically interpret it. That yeah, the question that you asked is a valid question, right? Even I can also ask that. See, how is it possible? I2 is 0. Therefore, how there would be a potential difference? And many students would simply write this equation I2 into XL2. Since there is no current, it is 0, but it won't be 0, because it is mutually coupled with two other inductors, and you also need to take that into account, right? So that is why you get this value. Okay.
Yes, sir. Sir, another one small doubt, sir.
Bolo.
Sir, you told me one example, na, sir, that two wooden piece we are winding the coil like that.
Uh-huh.
Sir, in the lecture, what actually told na, sir, a coil is wounded in the core, sir, primary and secondary. Through the
Ah,
core only, the mutually coupling will be happen like that, sir told in
yes,
the
that
lecture.
is in a transformer.
Is
That
only possible. Oh, that's different, sir.
no, that will also happen, na. That see in a
Then mutual
transformer.
coupling will happen only through only not through core, sir. Also through mm, air medium.
No, I just gave an example to explain the thing. But yes, it will happen through the core only. I mean, in a transformer, how is it designed? In that way only, yes. But if you take a wooden coil and you wound a inductor through it, a current will pass through it, right? Because the current is not flowing through the wooden coil. The current is flowing through the copper wire that is wound around the wooden coil, right? The current will definitely flow through it.
Oh, okay, sir. Then the wooden coil also act as a core, sir, at that time.
See, the design of the transformer is different. A transformer is enclosed, yeah, so as to protect.
Okay, sir.
It's the same, because the your current is flowing through the copper coil, right? Not through the wooden rod or whatever, the non-conducting part. It is flowing through the conducting wire. Code of a transformer means basically the, the primary part, primary winding, secondary winding. It is enclosed and it is very close by.
Yes, sir.
Yeah, those things are code, but they are enclosed. But the essential concept is the same. There also this thing is only happening. There is flux
Oh,
linkage,
okay, sir.
right?
Sir, in the lecture, what he told us, sir, actually, that leakage inductance will be there, and also mutual inductance will be there. Leakage inductance will be somewhat in its own, but sorry, leakage inductance, mutual inductance, it will be around the core. It will
Ah,
happen like that.
yes,
He
yes.
told.
Yes, that is true. Yes, there would be some leakage inductance
Okay, sir.
because of the design issues and all. There is lot of complications here.
Okay, sir.
See, if you study the design of a transformer, then I would say you go into deep of that. But here, since you don't try to confuse those leakage inductance with this mutual inductance and the inductance value, right? That is a different thing that you will understand while you're studying a transformer. Okay. But
Okay,
what
sir.
sir told is right, obviously, because leakage inductance will happen due to the its own inductance value, but mutual inductance will occur due to an inductance which is present nearby to that inductance, right?
Yes, sir.
Yes.
Okay, sir.
Okay, okay. Then we'll stop the session here, and I will be sharing these things probably by tomorrow. Yeah,
Okay, sir.
and
Thank you, sir.
yeah, and wish you a happy
Yes,
Holi
sir.
too.
Thank you, sir. Same to you, sir. Happy
Same to
Holi.
you. Thank you.
Bye, sir.
चलो